Yeah. So so the first line that gets printed in our output, I'm going to write it down here, is bad array. So after this catch block catches our out of bounds exception, once it finishes running, we have to go to the finally block. Uh, every time you have a try catch block and you have a finally block, the finally block always happens. As in like your first attempt, the try block, if you have an exception, it gets caught by one of your catch blocks and that executes the code inside. And then the finally block always runs. So the next line that comes after bad array will be let's go. Yeah. It's a little out of alignment, but it'll print right after bad array, basically. Next, once we run the finally block, we increment our I, and now our I is 0. So here we attempt the try block again, and we go to item 0 here. So we're going to attempt to parse as an integer what is at item 0. So this is our array items. What is at items, what is in the array at index 0 is the string 10. Since this string, this string is able to be parsed as an integer. So this method is able to turn this string into something that is an integer value. So this will successfully run. So since this doesn't throw any exceptions, we can run the try block, run the code inside the try block. So the next thing that gets printed is the answer is colon space 10. Yeah, 10. Okay. And after we run the try block, like I mentioned before, the finally block will always run for each iteration of the try catch block. So what comes afterwards is also let's go. Does that make sense so far? Okay.
How come bad array gets printed first?
Bad array gets printed first because our for loop starts at I equals -1. So when we run the try block, when we try to do the try block the first time, we'll go to integer.parseInt items I. So that means the first thing we're going to try is we're going to try to look at what's at
And
what's at the items array, yeah, in the -1 index, but that's not a valid index, so it's
right.
out of bounds. Yeah.
All right.
Okay. Let's see. Yeah, no problem. If we were put the answer, we should add the let's go as part of the answer also. Yeah. Because the finally block always runs. For every iteration of the for loop, one of the either the try block runs or one of the catch blocks runs, but the finally block also always runs for each iteration. So let's see what's next. Okay, so when we go to items, actually next iteration of the for loop, we increment the I. Now we're looking at what's at I equals 1. So at I equals 1 for items 1, we have exam. So let's go to the try block, and we're going to try to parse as an integer what's at items 1. And the string that is at items 1 is the string exam. So this can't be parsed as an integer because it doesn't contain valid integer digits. So that means that this is going to throw a number format exception because what you're trying to parse as an integer isn't formatted as a number. So the number format exception gets thrown. The try block fails, so we have to go look at our catch blocks. We see here that the first catch block here catches a number format exception. So what's getting run now is, or the next thing that gets printed is oops. And then we print what is at items 1, which is exam. Okay, and that happens because item what is at items 1 in the array is
Exam.
not formatted
And
properly as a number. Yes?
no, I was gonna say it's a string called exam.
Yeah. Let me check the chat. Okay, I see. All right. So next, oh yeah, next, the finally block will always run. So the next thing that gets printed is let's go. And now we're going to go to the next iteration of the for loop. So now we're at I equals 2. So we run the try block, where we try to run the try block. We want to print out the answer is integer.parseInt items 2. So at items 2, we have 20, the string 20. And the string 20 is able to be parsed properly as an integer. So there are no problems with this line. So that means this try block will run successfully. And the next thing that gets printed is, oh, okay, I'm running out of space. The next thing that gets printed is the answer is colon 20. But this will be under the let's go of the previous line. I just ran out of room there. So after the try block runs, we always run the finally block. So under that, let's go gets printed. Okay. So finally, let me erase some of the extra stuff I wrote. Finally, we go to the next iteration of the for loop to I equals 3. So at I equals 3, we have we're gonna try to run the try block again. And we want to print out the answer is integer.parseInt what's at items 3. So the string that is at items 3 is the string 5, but it's spelled out as a word. So even though we see this as a number, this isn't formatted properly as a number to the computer. So it can't be parsed as an integer. So this will actually throw a number format exception because the string FIVE is not formatted properly as a number, as an argument for this parseInt method. So the try block will fail, and we'll have to look at the catch blocks to see which of them can catch this exception. And luckily, the first catch block will catch the number format exception. So the next thing that gets printed is oops, exclamation mark, space 5. So after the catch block runs, we go to the finally block because that always runs after a try or a catch block. And we write let's go. So after the finally block, we'll try to increment I again to become 4. But now we've actually reached the stopping condition of the for loop because 4 is not less than 4. which is the length of this array items. So at I equals 4, we actually leave the for loop. So this would be our final answer. Oops. This will be our final answer, but with this part underneath this part, I just ran out of room. Any questions, everybody?
I understand. It's all good.
Okay. So exception
Dang.
E would only happen if if you couldn't match it with all the other exceptions. So if it wasn't a number format exception, and if it wasn't an array out of bounds exception, then you would go to exception E. So it's like it catches everything else. I equals 4 is just that the for loop will increment one more time, and it'll check the condition to see if it should run again. But it shouldn't run again because now it met the stopping condition for the for loop. I just wanted to demonstrate that. Okay. So I'm gonna move on to the next question. And I'm gonna erase all this. Does anybody need it still? Okay. So I'm gonna assume I'm good to erase this, and I'll move on. Okay. So next is let's see. What is the output when class question is run? Let me check. Okay, so it's another output question. What is the output when class question is run? We have the main function. We have an array. What is that array 0? Okay, so we're calling the constructor beta with input 1. All right, let me think about this. Okay, so first, the main function, we look at the main function first. The main function is first creating an empty array of type alpha with four um, four uh, four elements in the array of type alpha. And then at index 0, we're calling the constructor beta 1. So let's look at the beta class. So inside the beta class, which extends alpha, so that means it's okay to create an object of type beta inside this array because beta is descended from alpha. So that means the class, anything that is of class beta, also classifies as class alpha because beta is a descendant of alpha. So let's look at the constructor for beta. So the constructor for beta takes in an integer and then calls the super constructor. So in class, you might have learned about the super method or constructor. So the super constructor, what it does is if you have a class that extends another class, the first thing you should be doing in your constructor is calling the super constructor, which basically means you're calling the constructor of the class that is descended from. So since beta comes from alpha, if we're calling the super in beta with y plus 3, it's the same thing as calling looking at alpha's constructor and calling alpha's constructor with y plus 3. So alpha's constructor also takes in an integer. And it also calls super, but it's not descended from anything. So we don't have to worry about that. And then we look at its the lines of code after, which say that its constructor, when you create a new alpha, it'll print I am alpha and X is whatever you passed into the constructor. So if we look here, the constructor for beta is called with 1. So if so what gets passed into the beta constructor is 1. So here it's kind of hard to write this, but your y here would basically be equal to 1. So you're calling alpha's constructor now with 1 plus 3. So 1 plus 3 is 4. So we're passing 4 into this constructor. So the first thing that gets printed in the output is I am alpha and X is 4. I'm not sure if that was like the clearest explanation. So I'm gonna look at the chat to see if anyone has any questions. Okay. Does anyone have any questions about what I just said? I'm gonna try to explain it again. But basically, when you call beta's constructor here in the main function with 1, you're gonna look at the constructor inside of class beta. And basically 1 gets passed in. So currently y is equal to 1. And then the first thing that happens inside the constructor is you call the constructor of its parent class alpha with y plus 3, which is 4. So since we're calling the parent constructor, now we have to look at alpha, which is its parent class. And we pass in 4 into its constructor. And now we skip this part because alpha doesn't have a parent for super. But so it's fine for it to call super, but alpha doesn't have a parent, so it doesn't do anything. And then we look at this line, which determines the first output, which is I am alpha and X is 4. So that's basically the gist of it. I'm going to move on to the next line. So after the alpha's constructor gets called, we now finished with this line. So we have to go to this part next. System.out.println I am beta and y is what 1 because 1 got passed in originally as your y. So the next line would be the next line of beta's constructor. Okay. So after we run that line, we're basically done with this first element of the array. And now we go to the next element of the array, which is my array 1 is equal to new beta 3. So we're basically doing the same thing that we did in the previous part. So we look first at beta's constructor. We're passing in y equal to 3 now. And the first thing we do is call its parent's constructor with y plus 3. So that's 3 plus 3, which is 6. So 6 is going to get passed into alpha's constructor. We skip this line because it doesn't do anything, or we're going to run this line, but it doesn't do anything. And then we go to its print statement, which says I am alpha and X is 6. So that's the next line. Okay, and after that, we finished with alpha's constructor. So now we move on to the next line in beta's constructor, which is a print statement that says I am beta and y is 3, because that's the original y that got passed into beta's constructor in the first place. Okay. So after we run that line, we're finished with this part. And then we go to new the next index of the array, where we're storing a reference to uh, a new object of class gamma. So it's calling gamma's constructor, passing in 5 as into the constructor. So let me clean this up a bit. I'm going to clean up this part on the side for gamma. So we see here that gamma is also extending alpha. So that means gamma is also a descendant of alpha, which means alpha is its parent class. So that means gamma inherits all of alpha's methods and constructors, just like beta does. So when we call gamma, what got passed into, or when we call gamma's constructor, what got passed into gamma's constructor is 5. So that's your y for gamma's constructor. And the first thing we do in gamma's constructor is we're calling the constructors of its parent class. So we call it and we pass in y plus 5, which is 5 plus 5, which is 10. So alpha is its parent. So now we have to look at alpha's constructor here. And we're passing in as x 10, because that's what got passed into gamma's super constructor in the first place. And now we run super in alpha, but since alpha has no parent class, it doesn't do anything. And then we run its print statement, which says I am alpha and x is 10. So that's the next line that gets printed. And after we finish running that line, we're basically done with the parents' constructors. So now we can move on to the next line in gamma's constructor, which is also a print statement that says I am gamma and y is 5, which is the original integer that got passed into gamma's constructor in the main function. Okay, so after we finish running that part, we're basically done with this line. The next line will follow basically the same pattern as the previous constructor, but I'll go through it anyway. And I'll be erasing this, erase this, this, and this, and this. So now we're calling gamma's constructor, passing in 7 as its y. And then the first thing we do in gamma's constructor is we're calling its parents' constructors using the super method or constructor with passing in y plus 5, which is 7 plus 5, which is 12. So now we go to alpha's constructor, which is its parent class, and we're passing in as x the value 12. We call alpha's parent class super, but since alpha doesn't have a parent class, it doesn't do anything, and then we do its print statement. So what gets printed here is I am alpha and x is 12. And after that, the next line is you're going to go back to gamma's constructor here and run its print statement. So the final line is I am gamma and y is 7. I ran out of space. Tend to do that. Yeah, I ran out of space, but that goes under this line will go under this line. And that's basically the entire output. Any questions for this one? Or any confusion?
No.
Okay. I'm gonna clear the canvas, or I'm gonna clear my screen. Let me know if anybody still needs it.
I got a question.
Yeah.
For gamma 5, doesn't he have like a super alpha also, or no?
Uh, for gamma 5, you're
Yes.
asking when I go to alpha's constructor
Yes.
and I go here to this line, super.
Yes.
Okay, so alpha doesn't have a parent class. So even if it tries to call the constructor of its parent class, it's the same as doing nothing because alpha doesn't have a parent class.
Oh, okay.
Yeah, yeah. And you can tell alpha doesn't have a parent class because it's not extending anything here, unlike beta and gamma. Okay, any other questions? If you were to print the array, what would it print? Uh, you right now you can't really tell because you don't know what alpha looks like as a string, and you don't know what beta looks like as a string. They're not defined as string values. So these classes, as they are written here, don't give you enough info of what they're gonna look like printed. So like there's no really way to do that as they are right now. You don't need to know that about these. Mm, it depends on, let me think. Xeon, would it just be an address to the array? I feel like it's up to the user how you want to print the array. Ah, okay. So if you're trying to print elements of this array, it might give you just the address of where they are, or it might give you an error because it doesn't know what you're trying to do exactly. But I don't think that's something you need to know for this exam. I'm going to clear the canvas and then move on uh, for now. Okay, next question. Class string node string data. Okay, so it's a linked list question. Fill in the missing code for the constructor of the singly linked list which has a head node. So what we're trying to create in this constructor is so string node. For these kind of linked list questions, it's good to draw out what the node looks like and what the linked list looks like. So I'm going to draw out the string node. So here's data. Here's next. Let's see, string list. You have a first and last node. So for this one, we want to define what a single linked list looks like when it's empty. Because this one, no values are getting passed into this string list. So that means it's kind of you don't have a lot to go off of. So it's best to just assume that the linked list is going to be empty. And for Lord's class, he asks for he likes to have his linked list with a dummy head node. So that means you're gonna have a node a first string node um that points to or at you're gonna have a one node in your empty list that basically is gonna be your dummy head node. So there's gonna be nothing inside. And oh wait, I don't think I drew it properly. Sorry about this. Okay, for Lord's class, his linked lists have a dummy head node. So that means there's one node in your empty list that is being referred to as the first node. But nothing is going to be inside of it. There's no data. There's no data inside of it. It's going to point to nothing because it's an empty list. And it's also going to be referred to as the last thing in your list. So every time you add something else to your list, this dummy node is going to point to what's actually the first thing in your list, like the first actual thing that has a value in your list. So if you're trying to define this constructor, you'll need to create a dummy head node. So inside this constructor, first thing you want is string node SN. I'm just gonna give it a name SN equals new string node, and I'll use the constructor for an empty string node. So first create your dummy head node, and then you have to define you have to have your first this dot first is equal to SN, this dot last is equal to SN, and the current length is going to be 0. So basically what's happening here is this node is going to be your dummy head node. There's no values in it. So I didn't pass anything into the string node constructor. And then I'm going to refer to this node as my first node. And it's also going to be my last node. And since this is an empty list, the length is going to be 0. So that's basically what the constructor for an empty singly linked list with a dummy head node looks like. I'm going to check the chat to see if there are any questions. Didn't we create it in the string node list class as string node first? In the string list class here, these are just what's being shown here are like qualities that you want your string list to have. So like characteristics that you want your string list to have as an example. So it's basically saying every string list should have a first string node, but it doesn't tell you what it should look like. Every string list should have a last string node, and every string list should have a length. But you see, none of these are defined yet. In this constructor, the constructor for the string list, when the user uses it, you're kind of defining for them what a new string list should look like. See here, values for the first string node are being defined. Values for the last string node are being defined, and values for the length are being defined, if that makes sense. Oh yeah, the declare not initiated. Yeah. So I'll redraw this diagram to make it look a little clearer. But for the constructor, since Lord asked for a head node, it basically just means you have an empty head node. The data inside is null. The next thing in the list is pointing to null. Or the next thing that it's pointing to is just a no value. So in your empty list, even though there is a node inside of it, it doesn't have any value. It just helps you figure out where the first thing in the list, first actual thing in the list is. And so you want it to be indicated as the first string node and also the last string node. But it isn't actually. It doesn't really matter. But this is basically an empty singly linked list in Lord's class. And the length should be 0. Does anybody have any questions about this? Okay. Then I'll move on to the next part. But unfortunately, I might have to clear this part out. Well, actually, I could write on the document itself. I'm being, yeah, okay, I see. I am being a little dumb. Okay, I'm gonna clear this out. Let me know if you still need it. Okay, next part. I want a code for the prepend method, which should add a new node to the beginning of the list, not a new head node. This new node should contain the data given as the parameter. Okay, so for this one, this is the prepend method. Like I mentioned before, with the linked list questions, it's good to draw out what's happening. So I'm gonna draw a linked list, arbitrary linked list with just some stuff in it. So it's so I have more stuff to work with. This is the dummy head node. This is the dummy head node. As you can tell, because it's being referred to as the first thing in your list. I'll have the last thing in my list, and all these things are string nodes. So the first thing, the dummy head node is pointing to the actual first thing in your string list. And then that thing is pointing to the next thing in the string list, and that thing as well is pointing to the next thing in your string list, and the last thing in your string list is pointing to a null value. Okay, so for my prepend method, what I want to do is I want to add a new node to the beginning of my list that contains this string value. So the first thing you want to do in the prepend method is create that new node so that you can actually insert it. So the first thing I want to do is I want to create a new node, give it the value that was passed into the method here in prepend, and so yeah, the first thing I want to do is create it. I'm going to name this new node n, and I'm going to write the code that corresponds to creating it. Let's see this. Okay, don't do that. Oh God. Hmm. Well, I can't see that. Let's see. Oh, I'll just write it here. Okay. So string node n is equal to new string base string node. And I think I just call the constructor for string node and I pass in value. And that should create my new string node with value as my data. So once I have this, what I want to do now is locate what the actual first thing in my list is, which is this node. So if I have my new node and I want it to be my new actual first thing in my list, that means I want to put this node here before what my actual first thing in my list is. So I can get it here by taking my first let me rephrase this. So I know what the actual first thing in my list is because my dummy head node is pointing to it. So that means first dot next is always equal to my actual first thing in my list. And you can see that in this diagram a bit because this is my dummy head node here, and it's pointing to what my actual first is. So if I want to insert my node there, the first thing I have to do is make sure that it's pointing also at what the actual first thing in my list is. And the reason why I want to do that part first is because if I do that part first, I don't lose a connection to the next part in my list. So that's the next line of code you want to write is n.next. I want it to be equal to first.next. So first.next, like I mentioned, is what is the actual first in my list. So once I have this, what I can do now that I have saved the location of what was my previous first, my previous actual first, is I can now break the connection between my first node, my dummy head node here, and have it now point to my end node, my new node. So once I have it pointing at my new node, now my new node is equivalent to my first.next. So now it's become the actual first. So the next line you want to write is first.next is equal to n. And that should be it, I think. Let me see. Oh yeah, and one last thing is you also want to check if your list might be empty. Okay. Oh yeah, an update length, sorry. And then the next thing you want to do is say length plus plus. And the next thing, let me think. Yeah, okay. And I'll explain the diagram again. Make it simpler. Oops, I think I accidentally erased that part. Okay. So here's your dummy head node. And here is your new node that you want to put in. So the first thing that you want to do here is well, let me show you what the wrong thing to do would be. If I just break off the connection between if I have my first dummy node first point to my new node, now it's pointing to my new node. My new node can't find what the previous first node in my list was here because now I don't have that connection anymore. So if you do this first, you can't then do this because it doesn't know how to find this part again because you lose the reference to that node. So actually, the first thing you want to do is the first thing you want to do for is save the connection or save this place. Save this place by having your new node point to what first is pointing to. And then once you have it pointing to what first is pointing to, now you can break off that connection and have it point to the new node. So essentially, you're kind of saving that place first, and then making it the actual first thing in your list. Sorry if that was a little confusing. Sorry, Jacob, was that clearer this time or? Okay, I'm glad. Let me see. So, huh. And I think one more thing that I want to add is you might want to check if there might be a special case where actually your list is empty and you just have the dummy head node. That means it's also the last thing in your list. So in this case, for prepend, it means your first and your last are pointing at the same node. So if you want to check for this case, you have to use the if statement. If first, um, if first, if this dot first is equal to this dot last, then what you want to do is set last equal to n to indicate that it's the new last thing in your list. As in, so now you want to say that this is the new last thing in your list because you're making it happen after you're putting it after the dummy head node essentially. And then you can say and then you can say first n dot next is equal to first dot next, and first dot next is equal to n, and then update the length. So this is a special case that you might want to check on the exam. I don't know how strict he is about it.
Kathy?
Yes.
Yes, someone was asking, is it possible to cover the append method, like appending anywhere arbitrary?
Okay. I'll cover the append method then. Okay. So this is the prepend method. Is you're trying to insert it at the beginning of the list. If you're trying to insert at the end of the list, there's a it's a little different. So I'm gonna clear my diagram down here. Oops, accidentally erased that part. Oh, God. String node n equals new string node value. Oh God, why? Okay, I'll just ignore it for now. So for the append method, I'm gonna use the same kind of diagram. Uh, so last is pointing to the last thing in your list. First, I'll make it very small so you know it's a dummy head node. This is pointing to nothing. So now, similar to the prepend method, you want to create a new node n and give it the value using the string node constructor. I'll rewrite that code actually. String node n equals new string node value. So what you want to do now is insert it at the end of the list.
Kathy,
Yes,
I think what you're describing is the postpend.
postpen.
It's like appending somewhere in the middle, not usually the end.
Oh, okay.
Like you'll pass in the current, like the
Append
value.
usually means at the end. But I think if you're talking about navigating the list and inserting it in the middle, right?
I'm not sure what David is asking. Maybe he can say.
Okay, David, tell me what you want, David. Okay. In that case, what usually happens is that kind of method, usually they ask you to find a value in the list. Let's say your list contains a bunch of numbers. This is 1, I'll say this is 3, and this is 5. Usually it tells you to try to find where your new node fits inside the list. So the first thing you have to do is go through your list and find the appropriate number that your thing is between. So I'll show you how to do that as well, which is, let's say your value is 2. So the first thing you want to do is you want a pointer in your list. You want a pointer in your list, and your pointer is going to be also a string node with value 2. Why did I draw it again? Okay. Yeah, so for this kind of thing, you want to search through your list. The first thing you also want to do with this, similar to the prepend method and the append method, is you want to create a new string node to act as a pointer in your list. You can give that string node the value that you want to insert between any two nodes on your list. And then what you want to do is start your pointer at first dot next, and then while start your pointer at first dot next. So now your pointer, even though your string node looks like this, I'm just going to draw it as a P pointing to something. The pointer is now pointing here. If the value here is less than P's value, and the value here is greater than P's value, then you would it's pretty clear that this is where P should be. So what we want to do is while P dot next dot value is less than or equal to P dot value, we want to increment P. I'll explain this code in a bit. So what this means is if P is looking at this node currently, I want to kind of look ahead at what the next node has. So if I want to look at the next node, well, actually I made a mistake, sorry. It's been a while. Okay, so let me just redo this. So the first thing you want to do is you want to initialize a pointer P. You actually don't have to give it, don't give it a value. And then you want to set P equal to first dot next. So now basically you're looking at the actual first node. Well, actually P equal to first. And then while P dot next dot value is less than value, which is what the value that I want to assert in between two nodes, then you want to keep incrementing P. Okay, so I'll explain this code, I'm sorry. So P is pointing here. So that means P is kind of equivalent to the node here. You want to look ahead at the next node. So the next node is going to be here, and you want to look at its value. So if this value is greater than the value that you're trying to insert, then you know that you found the place where you should be inserting your new node. So that's why if the next value is less than the value that you want to insert, you just want to keep moving your pointer P to the next one and then to the next one until you find the place where you're supposed to insert it. So that's a condition for the while loop that you use to keep incrementing your pointer. Once you're out of the while loop here, that means you found the place where you should be inserting your new node. Yeah. So there are a couple of conditions, or there are different cases for where you might be inserting your new node. The first condition is you might actually be inserting it in the first. You might actually be inserting your new node at the first part of your list, as in it will become the new actual first node. So if you want to check that condition, what you can check is if first dot if P is still equal to first, then you're inserting it in the first part of your list. So you're basically prepending. So if you're prepending, just use like the same code that you see here. Well, actually, no, maybe let me think. If it's the first node, then no, I can give you the code here. Yeah, it might be okay. So you can check if it's going to be inserted as the actual first in the list. If P is still equal to first, that means you're inserting it as the actual first. So what you want to do is set P dot let's say I created the node n with my value n dot first dot next is equal to n, and last is equal to n, and then length plus plus. Oh, I ran out of room. So this is basically what you want to do is you just want your first dot next to be equal to n, and then update the last part of your list to be equal to n, because oh no, if it's just the first node, just say first dot next is equal to n, length plus plus. It's a little complicated. Sorry. If P dot next, if P happens to be the last part, this is the second condition is you're inserting it in the last part of your list. That means P is equal to last. That means what you want to do is now make last dot next equal to P, and then oops, my formatting. Okay. Make last dot next equal to P, and then make P last dot next equal to P, and then make last equal to P. Yeah. So last dot next here connects P to the list because now what was previously the last node is now pointing to P. And then you update what becomes the actual last of your list to P. And then if neither of those are the case, it means you're inserting it in between two nodes. So what that looks like if you're inserting it in between two nodes, like in this case, oh, sorry, it shouldn't be P here. these should all be n. Oh wait, these should all be n. I'm sorry, I'm a little mixed up. But yeah. So the third case is you're inserting it in the middle of your list. If you're inserting it into the middle of your list, what you want to do is your P should be pointing to the thing that comes before your new node. So what you want to do is have your N point to what P is pointing to, and then have what P is pointing to become N. So you first update the connection of N to the next thing in the list, so you don't lose the next thing in your list. And then you update the node before to point to N to reconnect the list. So what that looks like is going to be else P N dot next is equal to P dot next. And then you have P dot next is equal to N. So that's kind of like what the code should look like for if you want to insert it, if you want to try to find the place where it should be in the list and then insert it there, is you might have to break up this into like 3 different cases. Sorry if it was a little mixed up. Yeah. He's done append, he's done prepend. You should know all of them. He's also done search. Kind of like what I did here is search where it should be in the list. And I'm not and maybe insert it, but usually when you're searching, you should know how to have a pointer that points to the first thing in your list, and then increment it to print out everything in the list. I think he should have the code for that in the PowerPoints if you do look at them for the linked list sections. Any more questions about this? Oh yeah, and afterwards, don't forget, you should always update your link. I keep forgetting to do that. But I'm gonna clear this in a bit and work on the equals method. If there are no more questions about append and prepend method. Okay, then I'll move on. Okay, next part is write an equals method for the linked list class. 2 lists are equal if they have the same length and the data of each corresponding node is equal. You need more space to continue, blah, 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 blah. Okay. So this one is basically what I was talking about, where you need to know how to have a pointer to your list and increment through it. So for this one, let's say this is my first list. And this is my other list. So what I want to do is I want to create 2 pointers. I'll name them P and I'll name them Q. These will also be string nodes, by the way. But they'll basically be pointing to references. They'll basically be pointing to string nodes in these lists. So I'll draw the dummy head node pointing to the thing, and this one too. So this is going to be this, and this is going to be other. Okay. So the first thing you can do that makes it very clear that the 2 lists are different is you can first check their lengths. So if this dot length not equals other dot length, then you can return false. Is Java false always capitalized or is it always lowercase?
Lowercase.
Okay, lowercase. So the first condition you can do that's very easy is if their lengths are not equal, they're obviously not the same list. So you can just return false immediately. And then after that is when you can create your pointers. String node P is equal to new string. Actually, I don't need to do that. String node P is equal to this dot first. And then I can create string node Q equal to other dot first. So this is just referring to your the current, or like because these are methods inside the class string linked list. This will just refer to the object that you're currently working with, and other is the object that's getting passed in. Okay. So while P while P is equal to Q, while P dot value is equal to Q dot value, then I just want to keep incrementing P equal P dot next. And then Q equals Q dot next. Let me think about this. So if they're incrementing through the thing, they're gonna keep going until no, wait, I wrote that wrong. Yeah, I thought so. Why did it do that? Oh God. Okay, sorry. If this dot length not equal other dot length, return false. Okay, and the while loop is just keep doing it while P dot next not equal to no, and or Q dot next not equal to no. I think check that. Okay. So you want to keep incrementing them. I forgot to initialize them. Okay. String node P equal to this dot first, and string node Q equal to this other dot first. So while they still have a next node to go to, I want to first check if P dot value is equal to if P dot value is not equal to Q dot value, well, P dot value is not equal to Q dot value, or if P dot value, the value of P's current node, whatever P is pointing to isn't equal to the value of what Q is pointing to, then the two of them are not the same linked list, and you can just return false. Otherwise, if that's not the case, then you can just keep incrementing P to go to the next node and Q to go to the next node. And then if you're out of the while loop, that means you've checked everything. Because the first thing that we checked in this method in the first place is if their lengths are equal. So if we got past this point and got here, it means they both have the same length. So first we have P pointing to the dummy P be equal to the dummy first node, and Q be equal to the dummy first node of the other linked list. And I just keep incrementing them. I keep them going in the while loop until they reach the last node. And for every node that they go to, I check if their values are equal. If they're not equal, I return false. Otherwise, I just keep them going. And then I only know that the two lists are equal when I've checked everything. And I only know that when I've left the while loop. So then that's the only part where I can return true. So that's basically how you would do this kind of question. I'm going to check the chat for any questions. Oh, yeah, you can also use the length to go through the linked list. Let me think. I think you might have to do the mental calculations in your head to like the how many times you might have to do that. But it is possible since you already know the length. Since you do know the length of these linked lists. It's just this is another way of doing it. Are there any questions for this question? If not, I'm gonna clear the canvas and move on. So, okay. And next question, GUI. Can you use a for loop? Are you supposed to do +2 every time since there's a no and string each? I've never done it that way, Leo, so I can't tell you off the top of my head. Maybe if there's time after the GUI, I'll try we'll try to figure it out. Okay. Okay, so GUI, this stuff is mostly just memorization. Yeah, this is just memorization. So the first thing is exam2 listener. This is an action listener. So it implements the interface action listener. I'm pretty sure that's correct. Yeah. So if you're implementing something, it's always an interface. In this case, for the listen, when you have something, the keyword listener, you're always implementing the action listener interface. Yeah, so that'll be the answer for part 1. Private something mainframe. So a lot of this, you'll kind of have a clue of what he's asking for, because what the classes is like kind of contained in the name of the variable. So here, this instance variable would be JFrame because it says mainframe, so JFrame. Next part, public void something action event E. So this is asking for the name of this method. The name of this method actually comes from the interface action listener, because the action listener interface makes it mandatory that you need to have define a method called action performed. So that would be the name of that method. And this is because since exam2 listener is implementing the action listener interface, the interface requires that this have the action performed method defined. So that has to be what's written here. Okay, string chosen item equals menu item get source get label. If chosen item dot equals blank, you want to print out hooray you passed. So the reason so for this one it might be a little hard to tell, but you have to read the question carefully because the answer for that actually is contained here in the prompt, because it says if the user chooses the menu item succeed, then it says the message hooray you passed. It misspelled you, but yeah. So if here hooray you passed is getting printed out, that means what has to be at 4 is succeed. And you need the quotation marks because it has to be a string. Else if chosen item that equals fail, then what do you want to print out here will also be contained in the prompt, which is if the user chooses fail, the message has to say, sorry, you failed. So, sorry, exclamation mark, you failed. So that's it for this GUI question.
Kathy,
Yeah, Zion?
according to Lord's solution, the second answer is main window.
Main window. Oh, let me, oh, I see. I was wrong. Okay. Main window is because here, they use main window. I'm pretty sure in this implementation, main window is extending JFrame. So that's your clue to what gets put here. Because here it says mainframe is equal to F. So yeah, I was wrong. Sorry about that. Yeah. Okay. Uh, it has to extend JFrame. I'm pretty sure mainframe, main window is, and its parent class has to be JFrame. Because exam2 listener or action listeners usually need a reference to the JFrame so that it knows what to be put on. But here, the way you would know it's main window is because the variable name mainframe is being used here. The instance variable name mainframe is being used here. And F is taken from here. So that's how you know it's the class main window. But yeah, I missed that. Any other questions about GUI? If not, I'll go back to the linked list questions or anything else anyone wants to go over. For this one, I think it's mostly Lord goes over the action listener questions. Did you guys do GUI in your last exam? I think you should just try to memorize some of the menu bar, file menu things, uh, how to put menu items onto menu bars, things like that, like what you worked on in your projects for the GUI stuff. That stuff is pure memorization. Uh, so I would recommend looking those over and seeing how you did them. Oh, cool. Good job, Zion. Any other topics you've learned for us to know how to exam? Uh, I think though with the output questions, those can be tricky. Just make sure you understand um inheritance very clearly. Like the super constructor, things like that. Uh, those are those can trip people up, I think. Uh, and the linked list, I think. I think he always puts linked lists on the second exam. Yeah, but I can't tell which way or another. What was it? Leo, is Xeon's method good enough for you, or are there any other questions that people want to go over? I think this was the last one. I'm gonna clear the screen for a bit. Oh wait, no, is there? No, that's the last one. Any other practice questions that people want to go over? If not, I might go over the append method because I don't think I ever really went over that one. So I have a linked list. I have my dummy first node. I have my last node pointing to the last thing in my list. And I guess Xeon, you could send out the feedback forms for now since things are kind of winding down. Okay. Yeah, so for the pen method, it's like the pre-pen method, except instead of adding it to the front of the list, you want to add it as the last thing in your list. So you have a reference to the last node in your list. The thing that you want to do is first, you don't want to lose a reference to what the last thing in your list is. So what you want to do is have it point to your new node first. And then you want to update the last to now be pointing at your new node. So that's essentially what you have to do here. The code for that looks like this. Public void append string value. So first you create the new node that you want to add in. And then you want to also check if your list happens to be empty. So if first is equal to last, that means your list is empty because they're both pointing at the dummy head node. If that is the case, then you also want to do first dot next is equal to n. Because now you have to create an actual first node in your list, if that makes sense. And then, okay. Okay, and after that, what you want to do is take the last node in your list and have it point to your new node so that you don't lose your reference to the last node in your list. And this way you're making sure it stays connected. Once you have that, just set last and update it equal to your new node. And then update your length. Always update your length because you just added a node to your list. And that's basically the append method. So for the pre-append and append method, you should always check if your list happens to be empty. If your list is empty for the pre-append method, that means you have to update your last, what is the last node, what happens to be the last node there. If your list is empty in the append method, you have to update what the actual first in your list is going to be now. Yeah. Any questions? For maps, if he did a lecture on maps, he might ask some questions about what maps are, but he won't ask you to implement them. When I took the class, he asked like, how do maps compare to tree maps, for example? And you can say like, hash maps are always constant time to access an element. Tree maps are always O of log n to like access find an element, basically. Tree maps, you can put things in order things like that. So you should just brush up a bit on what they are, but I don't think you need to know how to implement them or things like that. Recursion? I don't think Lord typically puts recursion on the second exam.
Oh,
Does he?
I mean, according to my lab professor, I mean, which is Gao, he said no. And I was just about to ask.
Hmm?
So so essentially the append method is just setting the value for the last node.
Yeah, append method, you're just adding to the end of the list. Prepend, you add to the front of your list.
All right. And for the if statement, the reason why we have first equals last is let's say if there's only one node, that would technically be the first and the last node of the list.
Sorry, could you repeat that?
No, I was just
I got
wondering, like,
distracted.
no, it's all right. So I was just saying, like, for the if statement where it says first equals last, that's if we have
Mhm.
only like one node, right? Like how you mentioned earlier.
Yeah, yeah. If
Okay,
if it's just a dummy head node.
I see. Got it.
Yeah. I mean, you still have to know what string, you still have to know string methods, right? Because you might have to read some code and understand what the string method is asking. Um, I think you have to know, yeah, yeah, classes. I think you still have to understand how to make a constructor, you know? I don't know if you, I think you should at least know how to implement a class, and how to implement a constructor. On top of that, like I mentioned before, inheritance is gonna be a recurring topic in this class. That's what object-oriented programming is big on inheritance, like the extends, super things like that. Um, I can't tell. I can't really answer that question because I'm not sure how he'll how he'll decide this exam. But from my experience, the linked list questions and the output questions tend to be pretty similar. Um, on top of that, I think the another thing you guys should know is uh, what exceptions are, like the try-catch method. How to maybe kind of like in your projects, how to create a new exception extending from an existing one. Um, and also when these exceptions are thrown. So like with the I'm gonna clear this for a bit. So like with the output question here, like for this one, you have to understand that when you try to parse uh the string exam, it doesn't make sense to the computer because it's not formatted as a number. You have to understand that if you're trying to access an index that doesn't actually exist in the array, you're out of bounds. And things like that. Legal argument exception, like when you're trying to pass in something. Um, but I think that's a runtime exception. But yeah. Other than that, I can't really think of what else to go over. Unless anyone has any suggestions. Yeah, thanks, Zion. Yeah, so the feedback form helps us keep keep these review sessions going. Okay. But yeah, if anyone has any questions, you can still ask them. Otherwise, like, we're pretty much done. Um, Usually it takes around uh it'll typically be up Monday. Um, does he have other practice exams? Did he post any others on his website or on Brightspace? Otherwise, I think you could try to um see about asking people who might have taken the class before about their practice exams, but a lot of them are pretty similar to this one.